Hello, this is question 4 on your mix exercise 7 from the applied textbook from year 1. So the proportion of defective articles in a third-time manufacturing process has been found from long experience to be 0.1. Random sample of 50 articles was taken in order to monitor the production. The number of defective articles was recorded. Using 5% of significant level of significance, find the critical regions for a two-tailed test of the hypothesis that 1 in 10 articles has a defect. So our hypothesis would be P1 out of 10 or 0.1, and H1, if it's two tails, is going to be different than 0.1. Significant level or level of significance is 5%, and N is 50. But be careful because they say the probability of in each tail be as near as possible to 2.5%. So instead of making it smaller than, we are going to make it as close as possible. That means that your critical region is going to have two parts. Yeah? When it's different, I'm going to have a critical region that is going to be probability of X being smaller or equal than an A. This would be smaller than half the significant level in general conditions, but they say as close as possible. So instead of smaller, we are just going to assume that this, I'm going to write this just to make the difference, yeah? As close as possible as 0.025, and I have to find a B, again, as close as possible as 0.025, yeah? I can use the tables because this is a binomial. 50 is the last value that you have in the tables. Greater than that, you won't find it. You will have to use the calculator. But we're going to go to this binomial and find the closest value to 0.025. So is 50 0.1. 50 0.1 is this column here. So the second column, I'm going to zoom in a second. And we need the closest value to 0.025. So we have to choose between 0.025, so one above and one below. If you subtract from 0.025, this one is closer, yeah? This one is closer. So this one is closer. This one is closer. So your value is this one. And your critical region, so this A is going to be 1. Your critical region is going to be X smaller or equal than 1. And for the other part of the region, so for the right side, we really need to change this into 1 minus X smaller or equal than B minus 1, because we don't have that in the tables. We have the smaller or equal, not the greater or equal. We rearrange and we have that the probability of X being smaller or equal than B minus 1 must be close to 1 minus 0.25, which is 0.975. So again, we go to the table and look for the closest to 0.975. So I have to choose between 975. I'm going to get one below and one above. And this one is closer. The 9, yeah, the 9 is closer. That means that this value here is going to be 9, and therefore B, as that's B1 minus 1, is going to be 10. So my critical region is going to be X greater or equal than 10. So I have critical region 1, critical region 2. I'm going to reject the hypothesis 0 if my value is smaller or equal than 1 or greater or equal than 10. Yeah? State the actual significant level of the above test. Actual significant level is this probability, is the probability of falling into the critical region. So probability of X being smaller or equal than 1 plus the probability of X being greater or equal than 10. We are adding those two probabilities. We can do with the calculator, but we have the values here in the table, really. Yeah. So it's 0.0338. 0.0338. No, 0, 0, double 0. No, just 1 0. Sorry. 338 plus the probability of being greater or equal than 10, which is 1 minus the probability of being smaller or equal than 9. Yeah, so I'm doing this. So 1 minus smaller or equal than 9 is this value here, 0.9755. And this is 0.0583. So the actual significant level, if you want to give the percentage, actual significant level is going to be 5.83%, which is slightly larger than the 5%. So it just will be around this one. It could be above or below, but close to that. Yeah, that's the actual significant level. Then another sample of 20 articles. So instead of 50, 20 in this case, was taken at a later date. 4 articles were found to be defective, and we have to test at 10% significant level whether or not there is evidence that the proportion of defective article has increased. So our hypotheses are going to be p equal to 0.1, but now it's not double, it's not 2 tails, it's just 1 tail. So increase is going to be greater than. Observed value is 4. This means this is a binomial. We have now 20 articles instead of 50, so binomial 20, 0.1. And method 1, we are going to check the probability of the observed value, so greater or equal than 4, which is 1 minus probability of x smaller or equal than 3. Calculator, and it's 1 minus 0.8670, which is 0.133. And this is greater than the significant level, which is 10%. So this is greater than 0.1, just, but it's greater. Yeah, is greater. I have to accept 80 and write something like there is not enough evidence to say that the probability have increased. No, the proportion of defective article has increased. It's to support that the number of defective articles have increased. Of defective has increased. Method 2, with the critical region. So the critical region will be different because we have different significant level, just 1 tail, different end, so it's different. Probability of x being greater or equal than a value must be smaller than the significant level. We have to change that, a smaller one, a smaller than, so it's going to be a minus 1. This is smaller than 0.1. If I rearrange, I have probability of x being smaller or equal than a minus 1, smaller than 1 minus 0.1, which is 0.9. I go again to the table, but in this case is 20.01, and I look for the first one. Sorry, this is greater. That is greater than 0.9. Yeah, this is just rearranging this. 20.01. So 20.01 is this column here, and I look for the first one that is greater than 0.9, which is this one. So 4. This value is 4, therefore A is 5. So my critical region is x greater or equal than 5. Yeah, greater or equal than a, greater or equal than 5. The observed value is 4 articles. So 4 is not in the critical region. So 4 is not in critical region. Therefore, I have to accept 80 and all that. Yeah, so I'm going to write the same sentence. It's up to you which method you use. Yeah, and that's all with this question.